In this video, we're going to have a look at an A-star level question on the equation of a curve. So it does mention that C is given by parametric equations. What that means is just X and Y are written in terms of a different parameter, in this case T. When they're combined together to form a Cartesian equation, that's an equation in terms of X's and Y's only. It would be an equation of a circle actually. Oh, sorry, a curve. It says show that the curve C intersects the y-axis at exactly 3 points. So a curve intersects the y-axis specifically when x is equal to 0. So what we need to show is that when x equals 0, there's 3 roots to this right-hand side of the equation. And then we want to state the values of those t values. Let's do that first and then move on to the next part of the question. So making the expression for x equals 0, we have cos t and then in brackets 1 minus 2 sine t, all greater than 0. Let's think about where this is possible. We're making it equal to 0. Greater than 0 is at a later stage of this question, which is why I mentioned that. So it's equal to 0 when either cos t is equal to 0, because when that's the case, 0 times anything would equal 0, or when the bracket is equal to 0, 1 minus 2 sine t equals 0. And that's because when the bracket equals 0, then cos t multiplied by 0 will always give you 0. Alright then, when you're trying to find the value of t here, you do the inverse cos of 0, and that will get you two solutions that fall within this domain. Well, the first one that gives out from your calculator is pi over 2 radians. If we think about the cos curve, it'll help us think about the other solution. We know that cos curves, the values are reflective about pi radians, and meaning that if this value is pi over 2 to the left of pi radians, then pi over 2 to the right of pi radians, which is at an angle of 3 pi over 2, is where the curve is equal to 0 again. So the other solution is where t is equal to 3 pi over 2 radians. Moving on to this next part of the question, to solve this we're going to add 2 sine t to both sides, so 2 sine t is equal to 1, and divide both sides by 2, so sine t is equal to a half. When you now do the inverse sine of both sides, we get t is equal to the inverse sine of a half. And if we briefly draw out the sine curve, so I'm just going to draw it out like so. Again, dealing with everything in radians. Sorry if my drawing is horrible. We're interested in where it crosses a half. So we know the maximum value is 1. A half would be somewhere midway in between. This value here is the one that's given out from your calculator. In this case, that's a value of 0.479. Once again, using the reflective nature of the graph, you can use a cast diagram by the way, but using the reflective nature, we know that the distance from here to here is the same as the distance from here to here. If we do pi take away that value that we just got, pi take away 4.79, oops, sorry. Yeah. So pi take away 0.479, we get the other value actually, which is 2.66. So let's write 2.66 radians. And those are your 4 solutions for t. I'm going to increase the thickness of the pen because I'm realizing that it's a bit difficult for you guys to read. But those are the t values, and then once you find the y values at those points. All you have to do for that is substitute those t values into this equation. So for example, when t equals pi over 2, it will be sine of pi over 2, and then in brackets 1 minus 3 sine pi over 2. In this case, that will equal a value of minus 2. When you put t equals 3 pi over 2 into this expression, you get a value of y equals minus 4. When you put t equals 0.479 into the expression, you get a value of minus 0.176. And lastly, when you put t equals 2.66 into this expression, you get y is equal to minus 0.180. Perfect. Let's now move on to part 2 of the question, where it gets a bit more difficult. It says find the range of values of t for which c lies above the x-axis. If we think about a curve, where it's above the x-axis is where all the y values are positive. So we're interested essentially in where y is greater than 0. Let's take our expression of y and think about where it makes sense for it to be greater than 0. So if we think about multiplying two numbers together, there's only 2 options for it's greater than 0. Either when sine t is greater than 0 and the bracket is equal to 0, because 2 positive numbers multiplied together give you a positive number, which would then be greater than 0. Or the other option is both of them are negative. Sine t is less than 0 and the inner bracket is less than 0. If that's the case, when you multiply 2 negative numbers together, you get a positive that's greater than 0. Okay, then moving on to the rest of this question. Again, focusing on the sine curve, we see that it's greater than 0 in between 0 and pi. So let's form that. It's between when t is between 0 and pi. That's where sine t is bigger than 0. If we look specifically where 1 minus 3 sine t is greater than 0, we have to do a bit more working out here. Let's do it in a different color pen actually. We're going to rearrange this by adding 3 sine t to both sides. So 3 sine t is less than 1. Divide both sides by 3. If we first solve for sine of t is equal to a third, that'll help us to figure out whereabouts on the graph it is. So if t is equal to the inverse sine of a third, that'll get you a value of 0.34. Again, using the sine graph, if we say a third is around here, and this value here is 0.34, this value here would be 0.34 away from pi. So doing pi take away 0.34 will get you to that second value, which in this instance is 2.8. We're interested in where sine of t is less than a third. It's less than a third when it's between 0 and 0.34. Also, it's less than a third between this value here, which is 2.8, and also up to 2 pi. So when t is between 2.8 and 2 pi. Radians, by the way, everything's in radians. Now, what part of the inequality satisfies both of these? Because we want both to be true for values of t. Well, when 0 is in between, when t, is in between 0 and 0.34, that satisfies both of these. So that's the set of answers when t is between 0 and 0.34. Also, when t is in between 2.8 and pi, that satisfies both of these inequalities. So that's another inequality you can put for your answer. Moving on to this part of the question, there's nothing that satisfies both of these at the same time, because when sine t is less than 0 in this domain is between pi and 2 pi. Whereas this expression here, when you rearrange it, we get 3 sine t is greater than 1, sine t is greater than a third, but sine t is only greater than a third in between 0.34 and this value here, 2.8. So let's write that out, 0.34 and 2.8. There's no overlap or correlation between these two inequalities. So it doesn't exist where sine t and this inner bracket are less than 0. So there's only two inequalities that you write for your solution, which are these two inequalities here, because these are the only positions where both sine t and 1 minus 3 sine t are both positive. And so they'd multiply to give a positive integer, which would then be greater than 0. And then y would be greater than 0, meaning the curve C would be above the x-axis. Pretty difficult way of thinking about it, but hopefully that made sense to you guys. Be sure to like the video if it helped and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.